So we've already multiplied and divided. Now we are going to add and subtract. So we need to talk about a couple of things before we can start adding and subtracting. And those are the LCD and the LCN. What do those things stand for?
Least common denominator, least common multiple.
Agreed. My LCD is the least common denominator. And my LCN is the least common multiple. So let's think about an example of this. If I had the numbers 4 and 6, what would my least common multiple for those two numbers be? Not 2. 12. So remember, yes, so you kind of have to like switch gears. 2 would be our greatest common factor, right? But our least common multiple is the smallest number that both of them can go into. Does that make sense? So when we're thinking about that, why did we choose 12 and not 24? 12 is smaller. Well, how did we get to 12? Yes. Is there a way that we could do it a little bit more like strategically than just kind of like thinking, oh, I know those both go into 12? What would we have to look at? The factors, okay? So what are my factors of 4? 2 and 2. What are my factors of 6? 2 and 3. Right? So notice, in order for them to go into whatever number we pick, we have to have the factors that are listed. So my first one, I would have to list 2 times 2. So that takes care of these 2. Okay? Well, notice that this 2 now, it's already listed. So that also takes care of that 2. So I don't have to write it again. Does that make sense? But then notice that we do still have another 3. So we would have to do times 3. Well, what's 2 times 2? 4. And 4 times 3 is 12. So that's where we get our column from. So in general, our rule is going to be, when we're talking about factors, our least common multiple is going to have to contain each factor the greatest number of times it appears in one of our terms. expression. I like it. So in this case, my two expressions are 4 and 6. So notice that my factors are 2 and 3. Now what is the greatest number of times that 2 appears in one of those? 2. We all see that. Now it appears 3 times between both of them, but I only want to look at each one individually. It happens once in my 6 and twice in my 4. But my least common multiple has to have the greatest number of times it appears. 2 is bigger than 1, so it has to appear twice. Agreed? And then 3 appears 0 times in my 4 and 1 time in my 6. Which one of those is bigger? 1. So we have to appear 1 time. You all with me?
Yeah.
Now that's going to be true no matter if we're dealing with numbers or if we're dealing with variables. Okay? So this asks us to find the least common multiple of 6xy, 15x squared, and 9x to the 4th. So what do we have to look at in order to be able to find our least common multiple? The factors. So we're going to have to do the same thing here. So what are my factors of 6? 2 and 3. Well, my factors of x and y are just going to be x and y. Okay with that? Yes? Alright. So next up, what are my factors of 15? 3 and 5. And then notice that we have 2 x's this time. And then what are my factors of 9? 3 and 3, 9x, and 4y's. Agreed? Okay. So now, how many times did we say we have to pick one of our variables or numbers? The greatest number of times that it happens. Okay? So notice that on my first one, if I pick this 2, right? Well, I only have 1 2 there. Do I have a 2 anywhere else? No. So once is going to be the greatest number of times that it appears. What about my 3? I have a 3 here. So if I write down the 3, that takes care of this one and this one. Well, what's the problem? I'm missing another 3 because how many times does it appear in 9? Twice. So I have once, and then twice. So the greatest number of times it appears is twice. Okay? So then our next factor is x. What's the greatest number of times that one appears? Also twice. So what's the other way that we can write x twice? X squared. Alright. And then lastly, I have a y. Well, what's the greatest number of times that y appears? 4 times. We have to have y to be 5. Yes, we have a 5. I did that last time too. For whatever reason, I don't like the 5. We're going to have a times 5, and then we have our x squared times y to the 4. Alright. So then, if we combine everything, 2 times 3 is
6.
times 3 is 18 times 5 is 90. So we would have 90 x squared y to the 4th. And the way that we check ourselves on that is by saying, can 6xy go into 90x squared y to the 4th? All my 6 can go into 90, and then the x and the y can both go into it. And you can do the same thing with your other things. Does that make sense? Now, what's different about our next problem? So, instead of just having monomials, what do we have? We have trinomials, okay? But the process doesn't change, so what do we still need to look at? The factors. The only difference is, this time, instead of just being able to break them apart, we're going to have to use a method of factoring instead. Well, that's okay. So, what do our first terms have in common? Y. Sorry, this should be 4. They have a y squared in common, and then we're left with y squared plus 8y plus 15. And then does that trinomial factor? So you would be looking at what multiplies together to give you 15, that adds together to give you 8. 3 and 5. Okay, can I factor that any further? Nope. So then we're going to look at our second expression. So does this one have anything in common? We can't pull anything out, so we just have to use our AC method. So what multiplies together to give us negative 40, then adds together to give us negative 3. Negative 8 and positive 5. So now, if I look at my least common multiple, what is my first term? Y squared. Do I have a y in my second one? By itself. Do I have a factor of y in my second one? Like, is there a y hanging out at the front of my second term? No. So it happens 0 times in my second and 2 times in my first. So 2 is the largest number of times it happens. We're okay with that. Alright, so next, do we have a y plus 3 in our second one? Nope, so we don't have to worry about it. And then, do we have a y plus 5 in our second one? Yeah, but how many times does it happen? Once. So it happens once in both of them. So we only have to have it once in our least common multiple. And then lastly, we also have a y minus 8. So that would be my least common multiple. Now, for when we're working your homework problems, or your test, or quiz, or anything like that, leave this in factor form. I do not want you to spend the time multiplying that out. It's not going to be very pretty, and it doesn't help you with anything. So just leave it in factor form. So that would be our answer. Does that make sense? Questions on either one of those? Agreed? Alright, so remember, we talked about our least common multiple with like 4 and 6, correct? Now, we can find the least common multiple like we did on the previous page, just for the sake of it. But most of the time, we're going to be finding a least common multiple in order to find the least common denominator. Because remember that in order to be able to add or subtract fractions, what happens? to be true.
Your bottom should be the same.
Your bottoms have to be the same. The denominators have to be the same. Because remember that your denominator is basically what tells you how many pieces you're breaking it into. So like if I had a pizza, and I was breaking that into 4 pieces, and I had one of those, and I was breaking it into 6 pieces, and I had one of those, and I wanted to tell you, like, what percentage of the pizza I have now, I have to figure out a way to combine those together, like a 1/4 of the pizza and a 1/6 of the pizza. Does that make sense? So the only way to do that is to come up with like a common language between them. And that's where we get that 12. Because if I break my pizza into 12 pieces, well now they have a common number of pieces between them. Does that kind of make sense? They all with me? Alright. So in the process of combining these, what would we have to do in order to make our denominators the same? Yeah, so we already found our least common multiple. We said that it's going to be 12. So if we know that it's 12, I need my denominator to be 12. What do we do?
Multiply.
4 by 3.
Agreed. Just the 4 and just the 6?
Not the
Wait,
line.
top.
Ah, why do I have to do it to the top as well?
Because
Yeah, so technically those are 1, right? So I'm not changing the actual value of it. I'm just changing the way that it looks, right? If I have 1/4 of a pizza and I have 3/12 of a pizza, I have the same amount of pizza. It's just how I'm describing it. How I'm like cutting with my pizza lines. Okay? So then this would become 3/12 plus 2/12, which gives us 5/12 of pizza. Are we all hungry now? Alright. Are we okay with that? So we're going to try and do a similar process with the problem that we have. Notice we have x's and y's in it. But the process is still going to be the same. So what do we have to figure out first? Okay, but before we can even figure out what to multiply them by, what do we have to figure out first? What we want them to be, right? So we have to find that least common denominator or the least common multiple first, and then we can figure out what we need to multiply them by. Okay? So I need to find my least common multiple of 2x to the third and 8xy cubed. Well, notice that 2 is going to be 2 times x times x times x. And 8 is what? So 3 2's. And then x times y times y. So for our least common multiple, if I just put 1, 2, right, that would take care of my first one. But notice that we have 3 in our second one. And remember, we take the greatest number of times that it happens, so that would be 2 to the third, right? Now, what's the greatest number of times that x appears? 3. Or what about y? 2. So we end up with 8x cubed y squared. So that's our least common multiple, which is also going to be our least common denominator. So it's acting like our 12. That's the denominator that I want both of my fractions to have. So now, we have to figure out what to multiply it by. So how did we choose 3 and 2 for our 1/4 and 1/6?
we took the least common multiple and divided it by the denominator, and that's what we got.
Yeah, agreed. Or another way to kind of think about that would be like, when in my multiplication, right? Like, what factor are we missing, right? So we can either divide, or we can just kind of think our way backwards and think, okay, like, what are we missing? So if I have 3y divided by 2x cubed, maybe, cubed y squared.
Or
Yeah, it's missing 2 of our 2's, which is also 4. And then we have x cubed, but we're missing the y squared. And just like with our fractions, whatever we multiply the denominator by to get our new denominator, I also have to multiply that to the top. So then I'm adding, and we have 5z divided by 8xy squared. Well, what is this one missing? It's just missing 2 of our x's, right? So we're going to have to multiply the top and the bottom by x squared. So then when we multiply fractions, how do we multiply? Straight across. Good. So 3 times 4 gives us 12, and then I have y to the third, right? And then 2 times 4 gives us 8, x cubed, y squared. Now, whatever's in my denominator should be my least common multiple. If it's not, then either we picked our least common multiple incorrectly, or we picked what we were needing to multiply incorrectly, or we multiplied wrong. So you would just need to check where did I mess up if they didn't match. Ours do, so we're okay. Then on our second one, we're going to get 5x squared z, and then we have 8x cubed y squared. So are our denominators the same now?
yes.
So can we add them now?
Yes.
Now, notice, when I added my fractions up top, okay, did I get 5/24? No, right? Because remember, the denominator is just basically how are we now dividing our pizza, our cookie, right? So instead of having like things broken up into fourths, or things broken up into sixths, we broke them up into 12ths. Well, even though we're adding pieces together, the way I broke them up is still going to stay the same. I still have 12ths. That part doesn't change, even if I add pieces together. So the same is going to be true here. My denominator is not going to change. Even though I'm adding my tops together, like the way that I broke it apart, it's still going to be the same in the denominator. So then what are we going to have on top? Well, y cubed plus 5x squared z. Okay, can we simplify that? Can we add them now? Okay, so what are they not? They're not like terms. I don't have the same variables. Okay? The only thing that we would need to check for is like if there was a common factor, which there's not, but like if it was a 6 instead, we could factor out a 2 or a 6. But if we factored out a 2, then we could reduce that with our 8, right? So the only time we would be able to simplify further is if there was something that was in common with our denominator that we could reduce. In this case, there's not. So that's our final answer. Just like my 5/12 was my final answer. I couldn't reduce it any further. So questions on that one? Okay, so let's look at another one. This one's going to be a polynomials instead of monomials, so that's okay. So what are we going to need to do first? Find the least common multiple. Well, before we can do that, what do we have to do? We're going to have to factor them. So we need to find the least common multiple, which means that we're going to have to factor. So on our first one, what can we factor out?
Yeah.
We can factor out a 6. So we're left with x minus 3. Okay? And then on our next one, what can we factor out? 3, 2, negative to give us negative 7. Okay. So we have and then we're going to factor by grouping. So we would factor 2x out of our first one. And the negative 1 out of our second one. So we end up with x minus 3 times 2x minus 1. And then I still have this 2 hanging out in the front. Now, if we're struggling with the factoring, we need to come in and practice with me on that. Because we're no longer just like factoring to factor. So we can't spend our time on the factoring steps. We need to be able to use our factoring to help us do other things. So if we need more practice with that, then we're just going to take some extra time to come in so that we can practice our factoring stuff. Okay? So then we need to decide on our least common multiple. So what's going to be the least common multiple between 2 and 6? Yeah, so think about your factors of 6 are going to be 2 times 3, right? So 2 appears in both 6 and 2, right? So I have to have 1, 2. And then 3 appears in the 6, so I have to have 1, 3. So 2 times 3 gives us 6. Well, then notice that we have an x minus 3 in both of them, so how many of those do we need? Just 1. We're okay with that. I'm not hearing much from the back. We all see that it appears once in both of them, so once is our greatest number of times it appears. So then what else do we need? Or what's our last factor? 2x minus 1. Okay? So it's going to be helpful to go ahead and write our fraction in factor form. So my first one, we can write as 6 times x minus 3. And we do that because I think it's a little bit easier to like see what we're missing if we write it in factor form. So if I have 6x minus 3, what factor are we missing to get to our least common multiple? 2x minus 1. So remember, we would have to multiply that to the top and the bottom. Same if we write our second one in factor form. We have 2 times x minus 3 times 2x minus 1. So what are we missing? Just a 3. Do we agree? So we have to multiply that to the top and the bottom. Well, that's nice. We don't have to multiply by any x's. So then we have 5 times 2x minus 1 divided by 6 times x minus 3 times 2x minus 1. This time we're subtracting. Be careful with that. And then we have 3 times x minus 1. Well, are my denominators the same now? Yeah. So we can do our operation. And what's that all going to be over? Our least common denominator. So the denominator just stays the same. Okay. So now, what do we need to do with the top? We need to simplify it because we are going to have common terms this time that we need to simplify. But what do we need to do first before we can combine our common terms? Distribute. So we get 10x minus 5. And then what do we get? Negative 3x plus 3, right? have to distribute that negative along with it. Be careful, this is a really common mistake. And then nothing's changed about my denominator. So then we get 7x minus 2. And does that have any common factors that we can reduce? No. So then that's our final answer. Okay with that. Questions? Okay. So let's look at one last example. Alright. So on this one, notice that we have a complex fraction. Okay? But this is kind of a different complex fraction than what we had on Monday. Because remember, on Monday, it was just like one fraction divided by another fraction. Yeah? This one, notice that we have like 1 plus a fraction, and then 1 minus a fraction. So we can't do our key change flip until it looks like what we had on Monday, where it's just like a bunch of divisions stacked up on each other, right? So that's where we're going to have to combine these, okay, in order to be able to rewrite it. Well, let's think, okay? What are my ones technically over? 1, right? So if I'm finding common denominator between 1 and anything else, what is our common denominator going to be? Just 1, not 1. Just what? The other thing. So if it was like 1 and 2, it would be 2. If it was 1 and a million, it would be a million, right? So if it's 1 and x, what would our common denominator be? X. So that means that we would have to multiply our first one by x over x. And if it's 1 and y, then our common denominator would be y. So we would have to multiply by y over y. So we're getting closer. We have more fractions now, but now we need to combine those to each be one fraction. So what are we going to have on top? X plus 1 divided by x, all divided by y minus x, just over y. Y'all okay with that? Okay. So now this looks really similar to what we did on Monday. I just have a bunch of fractions all stacked on each other. And so we can do that process that we talked about. I'm going to keep my top fraction. I'm going to change my big fraction bar to multiplication. And then I'm going to flip my bottom fraction. Do we have any common factors that we can reduce?
No.
Nope. So we're just going to multiply straight across. And that would be our final answer. Are we all okay with that? Now, there is one other way that we can do this. Okay? It's not like one way is the right way and one way is the wrong way or anything like that. They're just kind of different. Okay? So, notice here, if I was looking at my least common multiple of 1, x, and y, what would my least common multiple be? X, y. Are we all okay with that? So, what I would do, or the other way that we can look at it instead, is take that big, not so nice fraction, and if I multiply the top and the bottom by my least common multiple of all of the denominators, okay? Notice that we would have to distribute this, right? Because I have 2 terms on top and 2 terms on bottom. So I would get x, y on our first one. But then notice what happens when I multiply it to 1 over x. So this is technically over 1, right? By the next on the top, the next on the bottom. So they're diagonal from each other. So what are we allowed to do if they're diagonal from each other? Reduce them. So what would we be left with? Just over y. So we plus y. So then on the bottom, we would also have to distribute. So we would have xy times 1, which is just xy, and we're subtracting. But now, notice, what do we have diagonal from each other? The y's. So your y's would reduce, and we're just left with x squared.
And that one and the other one, they look like the same, but one like the factor.
Correct. So if we factor this, so notice I have a y in common on my top, and then an x in common on our bottom, we end up with what we got over here. Like I said, just another way of doing it. If you like doing the big fraction instead, and that's easier for you, do it like that. If you like getting rid of all of the fractions and doing these common multiples, do it like that. It's not that one way is better or easier or anything like that. It's just kind of which way makes